Thanks for coming here. You're a hero in AI era. Hello. Good afternoon. It's an honor to be here, and I congratulate DroidKaigi on its 10th anniversary. Today, I will talk about RAG. It's a Retrieval Augmented Generation with mobile applications. So I'm so excited to share my experience with you. Before we go any further, please allow to me introduce myself. My name is Jae-Chang Park. I'm system developer at DreamWalker company. And I'm enjoying to develop mobile apps and AI systems and contribute open source project. As a community activity, now I'm an organizer for Proto Seoul and GDG Korea. Feel free, contact me. Today, I will introduce a RAG app for DroidKaigi. And this app is built 100% natively for Android using Jetpack Compose. And finally, I will show you how to transition to an on-device RAG pipeline. AI stands for artificial intelligence. AI is no longer just a research area. It's becoming part of our daily life. We can talk about software development, healthcare, industry, and robotics without mentioning AI. Are you also using AI assistant features? According to a study published by MIT, using AI assistant tools can increase productivity by 40%. This picture shows the difference between AI, machine learning, and deep learning. As you know, generative AI is a part of deep learning technologies. LLM is a large language model that is a part of a new natural language processing. I'd like to sum up the difference between NLP and LLMs. The key point note here that LLM is a subset of NLP and are large language models pre-trained on an amount of data. And here is the history of NLP. NLP technology has improved very quickly since 2010. How did it fast development happen? It's because computing power get better. Almost all LLM states are based on this transformer model. We don't have time to go into deep dive or details, but in the right image, the left side shows the encoder, which uses attention, and the right side shows a decoder. Transformers have encoder and decoder, which has used attention. And LLM have a developing at a very rapid pace. As shown in this diagram, you can categorize them into closed source LLMs and open source LLMs like Llama and Gemma. On the right, you can see models that have been created using only the decoder part of transformer. So, can we train an LLM to build on our one language models? As an example, here's a model card of Llama 3, which was released as an open source by Meta AI. It takes 1.3 million hours to train a Llama 3 8 billion parameter model using a single GPU. If we calculate this, it means that training 8 billion parameter models which with a single GPU would take about 150 years. That's an incredible amount of time. The Llama 3 model is created using two clusters over 24,000 GPUs. The total cost amount 255 billion yen in Japanese. Based on this result, training an LLM and making your own LLM models may require significant investment and take a lot of cost. So, we need to fine-tuning techniques. Fine-tuning is a method of training LLMs that we can personally try at home or your local machine. If you are using a Mac, you can take advantage of Apple Silicons that unify memories and use the MLX frameworks for fine-tuning. Recently, fine-tuning has been involved based on the LoRa techniques. You can find detailed information about LoRa in the paper published by Microsoft. In simple terms, LoRa involves keep the weight of the original model and combine them with the weight from your data. It's simple. Alternatively, both OpenAI and Gemini offer fine-tuning capabilities, allowing you to create your own models. And there are also a hot technology called quantization. Here is an example to make it easier to understand quantization. The left side represents public LLM models. The right side shows quantization fine-tuning model. So why do we need to understand concept of quantization? And why is it important? So smartphone has less memory compared to the desktops or laptop. Usually it has about 6 to 8 gigabyte memories. Although AI-powered phones are coming with larger memory, over 12 gigabyte. On the other hand, microcontrollers have a very limited memory capacity measured in a megabyte. So to run the LLM on the small memory, you need to reduce the size of the basic LLM models. For the Llama 3.1 and 8 billion character models, the model size is about 60 gigabyte. And most of these consist of weight and bias values. So we reduce the model size by adjust the data type. If you quantize an 8 billion models to 4-bit, the required memory is about only 4 gigabyte, which is 87% less compared to original model. This shows the possibility of running an 8 billion model on our smartphone. And therefore, we will actually use the quantized and fine-tuned LLM models. Next, what is RAG? RAG is a stand for Retrieval Augmented Generation, and it starts from a paper published by Patrick Lewis in 2020, while he was working at Meta AI, it's on Facebook. Retrieval Augmented Generation is a software architecture and technique that integrates large language models with external information sources. So, why? Why did he start using RAG techniques? As an example, I asked GPT-4o Mini model about DroidKaigi 2024. The model reply indicates that the training data is up to date as October 2023. Yeah. It's the LLM challenges of having no sources and being out of data. Next, let's look at what happens when I ask same type of question. The model said DroidKaigi 2024 was already held in February. Yeah, it's not correct information, but model said it as if it's true. In this case, the LLM shown hallucination by providing incorrect information. So when using the ChatGPT or Gemini, it reduces the hallucinations by an enhanced response to questions about the Redis data by performing additional web searches and to retry current information. This is an example of the RAG techniques. So, and second reason, we want to create a LLM service specialized for our domain. Yeah, but the already trained LLM does not have our data, but that why we want to use the RAG technique to create our domain-specific services. A good use case example of RAG is currently experimental release of Notebook LM by Google. This app using Gemini 1.5 to upload your data and summarize it and answer your questions. Next, I would like to talk about development process of RAG. This diagram shows the process when I developed the RAG app. The first step is the hardware selection. You need to decide whether to run it on your cloud server, on your local machine, on your laptops, and so on. Secondly, you need to choose a RAG framework. To implement a RAG system, you have two options. You can either develop all functions yourself or use a well-made framework. For example, there are frameworks like LangChain or Llama Index. The reason for using a framework is that it can save development time. And generally we use LangChain. LangChain is an open source like framework for building LLM-based application. It primarily supports Python, but can also be used in JavaScript. Flutter can implement LangChain using a LangChain Dart package. If you are using Java or Kotlin, you can take advantage of LangChain for J. Both are open source projects. Next step is implement RAG. Here is a diagram and implementing RAG pipeline. It can be divided into a total 8 steps. Today I introduce how to implement each steps in the mobile apps. And this diagram is an important part of the RAG pipeline. The process of embedding the user query and sorting in the vector database, and retrieving data from vector database and generate answer via LLM using prompt. The embedding model is a deep learning model. It can classify it into sparse embedding and dense embedding. It's query embedding, it's like sentence embedding or text embedding. Yeah. It's a processing of performing your question into n-dimensional vector data using an embedding model. For example, OpenAI text embedding model has a vector size over 1500. It's super cool. A vector database stores embedding data and retrieves similar data to user query through similarity search. The similarity search primarily uses cosine similarity and Euclidean distance. There are so many other methods for similarity search. Here is a formula to calculate the cosine similarity on the embedding value. For example, if you take a two-dimensional vector data, the similarity between point A and B is a vector A and B, can be calculated as shown on the right. It's not difficult, exactly. Then we can calculate the angle between two vectors. When you're using query in embed and enter the coordinate system as a point C, the similarity search is performed at both A and B and result with a height similarity or alpha. This is a similarity search. As you can see, there are many different types of vector database available. You should choose and use the one of the best fit your RAG pipeline requirements. Next, I have summarized the method for using LLM. You can install the model on your local machine or communicate with the app via API. And in the case of your macOS, you can use the MLX server through MLX. The most commonly used approach is calling API that's the LLM service provider from your app. Here is a demo implemented with OpenAI and Gemini and Orama. Let's take a look at how to implement an LLM model based on API calls, so OpenAI and Gemini. First, I create a data class based on the OpenAI API documentations for using chat completion API. Next, I implemented an API client using Cato. And I set up the HTTP client and content negotiations for using JSON. The API key must be obtained from the LLM service provider and need to set up in your project. Next, I allow the state to manage messages in the view model. Next, I will explain to detailed implementations of send message method inside the view model. In the second send message method, I handle message sending and state updating. To use the OpenAI chat API, you need to specify the model you want to use. Next, the test is executed within a coroutine. You call the method defined in service or client. The remaining task is to implement the view or your widget. I use the text field to receive user input. I set up the remember and mutable state off. Next, I call the send message method of the view model inside the buttons callback method. It's very simple. The message UI is conditionally rendered based on the role of the message data. In Flutter, the circle avatar widget is available, but in Japan Compose, you need to implement it yourself. I use the implement draw circle of canvas. In the case of Gemini, the implementation can be a bit more convenient. Just add the Google AI Client SDK. But now the Google AI SDK is currently in preview and is recommended only for prototyping. In the view model, create the generative model object and specify the name of the Gemini model you want to use. Here is the process calling the Gemini API. It's very simple. You can call generate contents method and add a parameter like image or text to the content parameter in your request. It's a multimodal. We have a look at the basic concepts of each blocks from basic RAG pipeline diagrams and how to use LLM on the client side. The black box in the red blocks can depending on how you implemented of them. Next are the evaluation and optimization stage of the implemented RAG system. Evaluating the output of LLMs or RAG pipeline is never an easy process. Some methods involving using LLMs to evaluate their own generated contents, while others rely on human evaluation. Which option would you choose? Human or LLMs? Here is the diagram text explain how to evaluate RAG results. What's really important here is whether a person or an LLM is doing the evaluation. We need to create assessment criteria and standard for the evaluation. I mainly use RAGs as an evaluation tool. In my experience, the basic RAG pipeline generally shown as accuracy is 60 or 17%. To improve accuracy, you will need to refine the RAG pipeline or your black box. One tip for improving accuracy is that the position of the retrieval chunk from vector database can impact output. Therefore, simply removing duplicate result and rearranging the order of chunks can enhance the accuracy of your RAG pipeline. Well, everything is finished, but is it enough? You think? Do you think it's enough? In fact, there are many more processing left beyond the system infrastructure setups and cost or usage monitoring systems. Monitoring systems can be addressed using tools like Langfuse, it's open source, and Langsmith, as well as managing feedback and users. And there are various tools available, so you can choose the one that suits your applications. Next, I talk about concept of RAG and introduce a basic RAG pipeline. Next, I explain in detail how to implement a RAG app for DroidKaigi on the mobile app. But how should we process and how should we start? My initial concern was how to obtain session data of DroidKaigi. This problem was solved through the conference app. I found the API in the app that fetches session information, which allow to devise data, my strategies. First, I fetched the 2024 session information through the API and then combine it with speakers and room information. All the data was retrieved in English. Then I made each session into single paragraphs. Let's briefly introduce each steps. I called the API found in the conference as retrieval session information. It's a Python code. And I analyzed the API response data, and I found that the speaker and room information were separated in here. And I had to match them based on their IDs. I used the pandas libraries to perform a join operation based on the room and speaker IDs. Finally, the result converts into the PDF file, and you can read the PDF file any systems. Creating your data is also very important for building RAG system because pre-processing is affect your output. Next, Here is the architecture designed for initially planned RAG app. The vector database uses Chroma database. And the RAG pipeline is set up on the Python server with LangChain or Llama index. The main feature this architecture is that the whole RAG process can happen remotely. The client just needs to call API to get result from user input. And this diagram is detailed architectures when implementing the LangChain4j library. The two on the left show the result of using LLM through LangChain4j. On the right is the RAG app with the RAG pipeline using LangChain4j. First, add the necessary library for the implementation. I add OpenAI and Llama and Chroma. It's simply added. LangChain4j makes it easy and convenient to use the document splitter. For chunk size, you need to adjust it according to your data formats and requirements. After splitting the document, the next step is embedding each chunk using embedding model to obtain vector information. I used Llama embedding for this, and I installed embedded model. So I pre-downloaded an embedded specified model in my laptops and set up model name. And you can set up your model, the same model names. Once embedding is completed, you need to store the vector information in database. I ran the vector database in a Docker container and used the port 8000. You can use the port that suits your setup. Chroma database can also be used through API calls, but the LangChain4j, you can easily save vectors in collection without detailed implementation. Just this. Next is the retrieval step, where we get chunk through similarity search when your user query comes in. We set the search options and how many pieces of data to retrieve and the minimum scores for filtering. We perform a search in the vector store based on the configure embedding search request. Next is the prompt step. This is a part of prompt engineering, which should be improved based on feedback. We match the retrieve result with the context from query and user question in the prompt. Next is the generation step, where we can easily call the API using LangChain4j. You set it up, call OpenAI GPT 4o mini model, and they are defined in enum class called OpenAI chat model name. I declared a state variable inside the view model to store the conversation state for multi-turn conversation. In LangChain4j, the message type name is a little bit different. In LangChain, it's called human message, while in LangChain4j, it's called user message. User message, AI message, system message. You call the API through the generate method and get a response. It's very simple. Stream processing can also be done easily using OpenAI streaming chain model or Llama streaming chain model, while we handle the data state processing through the generate streaming response handler. After using LangChain, I found that amount of code writing decreased by about 48%. You just need to use the provide method without having implemented data models or client or service. This table shows the result of implementing a RAG app using LangChain4j. Everything is done by calling the API obtain result, except for the text splitter. Here's the pros and cons of LangChain4j. This is just my personal opinion, based on my experience using it. The pros are is allow for quickly implementation without the separate service client, and it makes it easy to build RAG pipeline. Almost 100 code line. The cons include the high learning curve. And it seems that the official document needs improvement, and it doesn't support all features of LangChain. Because it's open source, it's not maintained LangChain, there is a possibility that feature will be added in future Draw contribution. The limitation I experience is while using LangChain 4j or SFRO. First, when I am for on-device embedded and try to run embedded model on Android device, I encountered an error related to Onyx runtime library. Secondly, the on-device LLM can be executed. And finally, there are limitations to detailed custom implementation. Finally, this is my migration strategy for implementing on-device RAG. The initial architecture involving place all block inside your smartphone. This way, you can build a RAG pipeline and generate results without needing a network connection. The reason for building an on-device system is security and privacy. Our data can be stored and used somewhere else. We don't know where your data is stored and how it's used. We want to protect our data as much as possible. There are a few missions that need to be solved for the migration. Then first, how can I execute the embedding model on your smartphone? How should I run the LLM models, and how should I store embedded vectors? And how can I retrieve them through simulated search? It's a lot of things. This diagram shows the architectures resulting from my consideration. I will explain each block. The first problem I am to solve was configure the vector database and then implementing the retrieval. To solve this problem, I implemented it using object box that support on-device vector search. This code the table for storing the embedding data. The vectors will stored in chunk embedding columns. Also the metadata and raw data of the chunk will be saved, so you can be used later when needed. Then similar chunk method receive the user embedded vector as a parameter, and perform similarity search by passing the arguments. Object boxes perform similarity search using the nearest neighbor method. I was able to complete the implementation of the on-device vector database. Next, how to run the embedding model and the LLM model on the smartphone. There are TensorFlow Lite, and MediaPipe developed by Google. And we can use Onyx runtime developed by Microsoft. As you know, Onyx is an open source format created by Linux Foundations. In the case of MediaPipe, it supports both text embedding and generative AI executions. But here are the limitations of MediaPipe. This is the reason why I replaced it Onyx runtime. For text embedding, the only supported model is the universal sentence encoder. Only single embedded model. This has a dimension of 100, which is smaller compared to the other embedding model. To use LLM model, the conversion process is required, but the number of supported model is limited. Here is the diagram for implementing sentence embedding on the device. The tokenizer from Hugging Face is primarily based on the Rust language. The J9 library is generated for each system architectures through the JNI embedding models and utilize them for embedding. The actual encode method uses Onyx runtime to set tokenize to user input and then perform an encoding operate to obtain the vector. I used the all-mini LM model from Sentence Transformer. It has a vector dimension of 384 and shown 40 million stylos. It's a widely used model. The Onyx file is also provided, and I downloaded both models and tokenizer file for use. The model size is under 100 megabytes. Yeah. Make it a lightweight and appropriate for on-device embedding process. In addition to this, I used the BG small model developed by BAAI. It's a Beijing Academy of Artificial Intelligence. This code is the encode method. It's a set of the suspense method to be handled as a coroutine. I list the sentence as an argument, then tokenize it using the tokenizer. Then it performs the embedding process through for ORT sessions. It's simple, yeah. Next, it's a diagram for running on-device LLM. You can see the execution of this process at the top of the diagram. First, the model is loaded into memory. The tokenizer is initialized, and LLM inference is processed. Below, you can see what occurs each step. First, the desired model is converted into the Onyx file, which is identified the free converting step. The runtime for inference using Onyx runtime. On the right side is the actual result of the execution on the real testing device. Yeah. As you can see at the top of status bar, despite have no network connection, the inference and outputs are working well. But then you unzip the Onyx runtime's Android AIR file and copy the runtime files and header file into your project. Here is the library C++ file and header files. I used the LLM tokenizer from Alibaba, ML frameworks, M and N. I used the header, the utilize of Onyx runtime API. And you create and use the function, load the model, pre-process, and run LLM individually. This is a JNI code. The start LLM method inside the view model that takes user inputs and a prompt as the parameters. It retrieves similar chunk for the input augmented using get similar chunk. Then it performs sorting within the prompt based on the scoring. Next, the retrieved data is placed into the context field of the prompt. The reg prompt can be tuned to fit your system. Yeah. Run LLM method executes the local LLM model. It handles the inference process for the input. If your LLM response value is n, it calculates the tokens per second values and initialize the related variables. In other case, it updates output result in the state to refresh the UI. How about this? Simple? It's difficult. Here is the final implementation result. The migration works has been completed to allow the all reg preprime functions to be performed on device. But however, there is no silver bullet. There are still limitations. The LLM size is large, and so downloading and loading to model can take a lot of time and could affect user experience. Performance depends on user smartphone hardware, so memories and CPU and GPU. To improve your experience, we need at least 2-digit performance of 10 or more. In my case, I test the Galaxy A15, and average token per sec is 4.5. Recently, large language model has been increased in Windows side. For example, Gemini has an input size of over 2 million tokens and is capable of summarizing entire books in a prompt. As a result, there has been a lot of research comparing long context model and RAG techniques and PEFT is fine-tuning. This paper is published by Google DeepMind and the University of Michigan. It's a study compare the result between long context LLM and RAG. And the research findings indicate that long context model demonstrates a better result than RAG. And furthermore, multilingual support is very important. Handling Korean, Japanese, and Chinese will be important in Asia users because most language models are based on English data. Yeah. However, now more models are gradually support multiple models, multiple languages, and multilingual. Here is the summary of what I talk about today. And first, LLM is trained on large amount of data to perform NLP tasks. Then we explore the concept of RAG and the basic processing of the RAG pipeline. Additionally, we cover how to implement API-based LLM and look at how to use LangChain4j. And that is a Java version of RAG framework to implement RAG pipeline. And finally, we review how to migrate on-device RAG pipeline. And finally, what I want to say is that LLM have just a begin after going through the POC stage last and this year. Yeah. LLM and RAG is also a starting point, and I hope to can use your creativity to build any application to want with AI. Thank you very much for your attention. ご清聴ありがとうございました。